Quadratic summary. In this video, we're going to summarize all we know about quadratics. A quadratic can be written in three distinct forms: the general form, the vertex form, or the intercept form. First, let's look at the general form. In the general form, the quadratic is written as f of x equals ax squared plus bx plus c, where b and c can equal 0, a cannot. A represents the coefficient of x squared, b represents the coefficient of x, and c is a constant. C is also the y-intercept. So the y-intercept can be written as zero c. If a quadratic is written in the general form, you can derive the following information. If a is greater than 0, the parabola opens upwards, it looks like a U. If a is less than 0, the parabola opens down, it looks like an upside down U. You can find the axis of symmetry, which is always at x equals minus b over 2a, and the vertex is at the point minus b over 2a, f of minus b over 2a. So if we have the equation f of x equals 3x squared plus 6x minus 4, we know that the axis of symmetry is at minus 6 over 2 times 3, which is 6, which is minus 1. So the axis of symmetry is the equation x equals minus 1. The vertex is at x equals minus 1 and y equals, put minus 1 into the equation, so it is at 3 times minus 1 squared plus 6 times minus 1 minus 4. So y equals minus 1 squared is 1, so 3 plus minus 6 minus 4, which is y equals minus 7. So the vertex is at minus 1 minus 7. The second way a quadratic can be written is the vertex form. The vertex form is f of x equals a brackets x minus h all squared plus k. From this form, we know that h is equal to minus b over 2a and k equals f of h. We also know that the vertex is at h, k. So if we've got the equation f of x equals 3 brackets x plus 2 all squared minus 4, we know that the vertex is equal to hk, which in this case is equal to minus 2 minus 4. To get from general form to vertex form, we need to complete the square. Therefore, if we've got the equation f of x equals x squared plus 4x minus 5, and we want to change it to vertex form, we complete the square. So therefore, we halve the coefficient of x. So therefore, we've got x plus 2 squared. We subtract half of the coefficient of x squared. Don't forget the minus 5 in this case. Now we can simplify. So therefore, we've got f of x is equal to x plus 2 all squared minus 4 minus 5 minus 9. A quadratic in vertex form can also be seen as a series of transformations. For instance, f of x equals x plus 2 all squared minus 9 is transforming the parent function x squared by the vector minus 2 minus 9. Remember, if it's inside the bracket, it affects the x coordinate. If it's outside the bracket, it affects the y coordinate. If it's inside the bracket, it does the opposite. So plus 2 becomes minus 2, minus 9 stays the same. The intercept form of a quadratic is written as y equals a brackets x minus p brackets x minus q. If a quadratic is written in this form, the x-intercepts are at x equals p and x equals q. Let's take as an example the graph of y equals minus 1 brackets x plus 2 brackets x minus 4. The minus 1 tells us that the graph of this function is upside down, so it would look like an upside down U. The x-intercepts are at p equals minus 2 and q equals 4. So the x-intercepts are minus 2, 0, 4, 0. The line of symmetry, when written in the intercept form, is halfway between the x-intercepts. So in this case, halfway between minus 2 and 4 is 1. So the axis of symmetry is at the equation x equals 1. Therefore, the vertex is at x equals 1. To find the y value, we substitute 1 into the equation for our quadratic, so we get y equals minus 1 brackets 1 plus 2, 1 minus 4, which is minus 1 times 3 times minus 3, which comes to minus 9. So the vertex is at 1, 9. It is the discriminant b squared minus 4ac that determines the number and the nature of the roots. If the discriminant is greater than 0 or positive, a quadratic will have 2 roots. If the discriminant is equal to 0, the quadratic will have 1 root or 2 identical roots. If the discriminant is less than 0 or negative, the equation will have no roots at all, as the quadratic does not cross the x-axis. For example, if f of x equals 3x squared minus 2x plus 4, we know that a equals 3, b equals minus 2, and c equals 4. Therefore, b squared minus 4ac is equal to minus 2 squared minus 4 times 3 times 4, which equals 4 minus 4 times 4 is 16 times 3 is 48, which is negative, therefore 0 roots.